We end this section with this question of how do we know if a number is prime or not? It's a big question that people are doing in the world, the mathematicians and even novice or amateur mathematicians trying to find the largest prime numbers. And so thinking about how would we determine if a number is prime or not? Is 211 prime, right? Think about that, and here's an example that kind of walks you through a way that you would do it, kind of what we call brute force guess and test method that leads us to a rule. And so determine if 137 is prime. Well, what you would do is continue to test, right? First, by the test of divisibility, you know that 2, 3, 5. Remember, every number is a product of prime, so all we need to do is check prime numbers. And as you continue to check 2, 3, 5, you would continue 7, 11, 13, 17. You would continue to check. But what happens at some point is that you don't have to continue on. Once you know that, because we're only checking prime numbers, right? Since every number is a product of primes, you continue going, and at some point, notice 7 times 19, what you're checking, these columns are getting bigger, right? And then notice the other columns are decreasing. And so what's going to happen at some point is that you end up crossing over. Notice that we got back to this place of 7 times 19, 17 times 8, that we only have to check up to 17 to check it. And if we don't get it, then we know the number is prime. If nothing, we don't need to check 19. We don't need to check 23, right? And so looking at that as a guide, we then have this what's called the prime factor test. Again, you want to read this through again as I described it, but take your time to read that. But it leads us to the prime factor test, which says that to test for prime factors of any number, one need only search for prime factors, P, of the number we're testing, right, where you only want to check numbers that are smaller than or equal to the square root of n. So for example, is 299 prime? Well, what numbers? I want to check prime numbers. Well, how big? I want to check prime numbers less than 17.29. How did I get that? Well, square root of 299. Again, it's a rule we're following based off of this example, the rationale here. And you end up with 17.29. So all I'm going to check are these numbers here, 2, 3, 5, 7, 13, 17. That's all I need to check to see if it's prime. And what we find out is that once we check 13, we find out that 13 times 23 is equal to 299, right? And so we got this here. So this is composite. And so now what about B? What would I do on this case here? What we want to do is check to see if 401 is prime. And so what we do is we're going to check all numbers, right? I'm going to look for all prime numbers that are smaller than the square root of 401, which in this case is 20 point something here, 20 point something. And so all I want to check are 2, 3, 5, 7, 11, 13, 17. I do need to check 19 this time. And then when you check those numbers, what we find out that that since none of those factors, right, none of these go into 401, we know 401 is prime. So that's all you need. Those are the only numbers you need to check to see if they go into 401, if it's those 401's divisible by these numbers or if they're factors. And since none of them are, we say 401 is prime.